Hello and welcome to Animated Education. Today we are going to solve logarithmic equations. But before doing that, we need to know the properties of logarithms. So the main property of logarithm looks like this. Log base a of b is equal to x, and it is the same thing as a to the power of x is equal to b. Also, it's very important to know that a can't be equal to 1 and a must be more than 0 and b must be more than 0. Now, let's move to the first property. The first property looks like this. Log base a of b plus log base a of c is equal to log base a of b times c. The second property. Let's say we have log base a of x minus log base a of y, and that is equal to log base a of x divided by y. Third property. Let's say we have log base a of b. Now, it is the same thing as log base c of b divided by log base c of a. Now, to remember this, it's easy to think that we are changing the base and we are moving b, because b is higher than a, to the top and a to the bottom. See? At least that's how I remember it. Okay, the next property. Let's say we have a raised to log base a of b. Now, this is equal to b. Okay, if base of log is equal to base of our number, it's equal to simply the number in the logarithm. Okay, let's move to the next property. Log base a of b to the power of n is equal to n times log base a of b. So we are simply moving this n here. A very similar property is our last one. So let's say we have log base a to the power of n of b, and it is equal to 1 over n times log base a of b. So we are moving this here. Okay, now let's move to our first example. Let's say we have a log base 3 of 9, and that is equal to x. Now, let's rewrite this as log base 3 of 3 to the power of 2 is equal to x. Now, we are using our properties to move this 2 here, so we get that it is equal to 2 times log 3 base 3 of 3 is equal to x. Now, if we have a logarithm base a of a, it is always equal to 1. So this is equal to 1. So our x is equal to 2. Let's say we have x is equal to 36 to the power of log base 6 of 2. Now it is the same thing as 6 square log base 6 of 2. Now we need to multiply this 2 and log base 6 of 2. Once we do that, we get 6 raised to the power of 2 times log 2 of 6. This is because if we have a to the power of x and again raised to the power of y, we need to multiply these numbers, okay? So we get that a is raised to the power of x times y. So we did the same thing here. Now let's move this to here. Once we do that, we get that x is equal to 6 raised to the power of log base 6 of 2 raised to the power of 2. This will give us 4, so we have that 6 raised to the power of log base 6 of 4. Now we are using our properties again, and we get that x is equal to 4. Let's say we have x is equal to 2 raised to the power of log base 8 of 5. Now what we need to do is 8 is basically the same thing as 2 to the power of 3, and we get log base 2 to the power of third of 5. Now we are moving this 3 using our properties once again, and we get 2 1/3 times log base 2 of 5. Now let's move this 1/3 here on our 5, and here's what we will get. We'll get that x is equal to 2 to the power of log base 2 of 5 to the power of 1/3. Using our properties once again, we get that our x is equal to 5 to the power of 1/3. We can also write it as this. Let's say x is equal to 10 times 100 to the power of 1/2 times a log base 10. Now here's an important part. Logarithm base 10 is written like that. Let's put a here, that's a number. So also a natural log that has a base of e is written like that. Okay, let's put a number here. E is 2.6 something. Okay, e is like a pi, a number pi. Pi is 3.1415 and so on. The same goes to e, but I don't remember what goes on e. Okay, let's go back to our example. So we have 100 raised to the power of 1/2 times log base 10 of 9 minus log base 10 of 2. Now it is equal to 10 times 10 because 100 is 10 square, so we get 10 square, and we'll write all this thing. Okay, this will give, now we multiply 2 with both with this expression, and we get that 10 times 10 log base 10 of 9 minus 2 log base 10 of 2. Now we can move this 2 here, and we get that 10 times 10 log base 10 of 9 minus log base 10 of 4. Now we can use our properties once again, and we'll get that 10 times 10 log base 10 9 of 4. This will give us 10 times 9 of 4, because we're using our properties once again, and this is base 10, and this number is, and our base here is 10 also. So our answer is 90 divided by 4. This will give us 22.5. This is our answer. Okay, now let's say we have a log base 3 of 12 minus x is equal to 2. So now this is an actual equation. What we did before was basically calculating logarithms. Now we actually need to solve an equation. So the first thing to do is to make sure that our inside of a logarithm is positive. So we need to say that 12 minus x is more than 0. That's very important, okay? Also, we need to say that okay, let's do that. We need to make sure that in both sides we have a logarithm base 3, and how we can do that. Okay, so we know that logarithm base 3 of 3 is equal to 1. Now if we multiply this by 2, let me take another color. If we multiply this by 2, we will get 2, right? This will be 2. So now we need to use our properties, and here's what we will get. We'll get that it's the same thing as logarithm base 3 of 3 square, and that is logarithm base 3 of 9. So logarithm base 3 of 9 is equal to 2. Now let's write it here in our equation. So we get that logarithm base 3 of 12 minus x is equal to logarithm base 3 of 9. Now once we have in both sides logarithms as the same base, we can do something like that. Okay, we cancel our logarithms. Okay, I'm not sure if that's the right term, but we do that, and we get that 12 minus x is equal to 9. Now we are moving x to the other side and 9 to the other side, and we get that our x is equal to 12 minus 9, and it is equal to 3. Now it's very important not to forget this equation, this inequality. Okay, so we need to solve this and make sure that our x can be 3. So let's do that. Let's move this 12 to the other side, and we get that x minus x is more than minus 12. Now we multiply this by minus 1, so we would get x positive and 12 x positive. Okay, so when we do that, the sign of our inequality changes, and we get that x is less than 12. X is less than 12. So, and our solution is 3. So we solved our equation right, and our answer is 3. This is our answer. let's say we have a log base 4 of 4 minus 2x, and it's equal to 3. Now we need to do the very same thing. So first of all, we say that 4 minus 2x must be more than 0, and we say that let's rewrite all this side. So we say that log base 4 of 4 minus 2x. Now we need to express 3 in terms of log base 4. So here's what we do. We write log base 4 of 4. This will give us 1. Now if we raise 4 to the third power, we get, after moving this here, after using properties of logarithms, we would get that this is equal to 3. But we don't need to do that, okay? It's not necessary. So now we can simply cancel these logarithms, and we get that 4 minus 2x is equal to 4 to the third power. 4 to the third power is equal to 64, if I'm not mistaken, and this will give us. Now let's move this 2x to the other side and 64 to the other, and we get that 2x is equal to minus 60 and x is equal to minus 30. Now let's come back and solve this inequality. So minus 2x is more than minus 4. I'm moving this to the other side. Let's multiply this by minus 1. We get that 2x is less than 4. The sign changes. And after we divide it by 2, we get that x must be less than 2. X is minus 30, and minus 30 is definitely less than 2. Let's say we have a log base 10 of x minus 1 equal to 0. Now logarithm is equal to 0. Okay, let's first write that x minus 1 must be more than 0, so x must be more than 1. Now any logarithm is equal to 0, then the inside of logarithm is equal to 1. So any logarithm of any base of 1 is equal to 0. This is also an important property of a logarithm. Okay, so let's write it like that. Log base 10 of x minus 1 is equal to log base 10 of 1. Now we are cancelling our logarithms, and they get that x minus 1 is equal to 1. So x is equal to 2. X must be more than 1. We wrote it here, so our answer is correct. Let's say we have a natural log of log base 3 of log base 2 of x, and all this thing is equal to 0. So now we need to consistently do the same thing as we did before. Okay, so let's write all this. Let's rewrite it. So natural log of log base 3 of log base 2 of x is equal to 0. So now as I mentioned earlier, any logarithm is equal to 1, then it's 1. Is equal to 0, then it's 1 here. So now we can cancel our logarithms, natural logarithms, and we get that log base 3 of log base 2 of x is equal to 1. Now we need to do the same thing again, rewrite this side, and we get log base 3 of log base 2 of x is equal to, now log base 3 will be equal to 1, then inside of a logarithm is 3, so just like that. Now we can cancel our logarithms once again, and we get that logarithm base 2 of x is equal to 3. Now logarithm base 2 of x is equal to 3, then now this is equal to 1, so we will write 3 here, and now this is equal to 3. So our x is equal to, we are cancelling these, so our x is equal to 2 to the third power, and 2 to the third power is equal to 8. Also, I forgot to do one more thing. We actually need to be sure that our x is more than 0, so we had to write that x is more than 0. That's also important. Now let's say we have a log base 2 of x plus log base 8 of x equal to 8. Now I want to use one more property that we didn't use before, so let's rewrite this just as it is, log base 2 of x plus. Now we could write this 8 as 2 to the third power and move this 3 here, but let's change our bases, okay? So let's write it as logarithm base 2 of x divided by logarithm base 2 of 8. X is higher, so it moves up, and 8 is lower, so it moves down. That's how I remember it. And this is equal to 8. Now this will give us 3, okay? This will give us 3. So okay, let's write that. Logarithm base 2 of x plus logarithm base 2 of x divided by 3 is equal to 8. Now let's multiply this by 3 to cancel this 3, and we get that 3 times log base 2 of x plus log base 2 of x is equal to 3 times 8. So now let's simply add these logarithms, and we get that 4 logarithms of base 2 of x is equal to 24. Let's divide it by 4, and we get that log base 2 of x is equal to 6. Now, by using our main property of logarithms, we get that x is equal to 2 to the 6th power. Let's say we have a logarithm base x of 4, and it is equal to 16. Now it's important to say that x is not equal to 1 and x is more than 0. Now to get x, we use our main logarithmic property, and we get that x to the 16th power is equal to 4. Now let's take a root with an index of 16 to both sides, and we get that x is equal to 4 of the root of 16. Okay, so actually we can simplify this, and it would be 2 square of 16th root, and this will give us 2 of eighth root. Let's say we have a logarithm base x of 9 and it is equal to 3. So we could solve this a bit differently. So we could use the same thing that we did in our all previous examples. So we could write this side as a logarithm base x. So a logarithm base x of x is 1, and if it's in the third power, it is this will give us 3. So we can write it as log base x of 9 equals to log base x of x to the third power. Now we cancel our logarithms and we get that 9 is equal to x to the third power and x is equal to 9. Okay, so yeah, it's also important to say that x is not equal to 1 and x is more than 0. So yeah, that's how you solve logarithmic equations. I hope you understood, and see you next time.